Good morning, students. In the last lecture of the operating system, we were seeing the concept of scheduler and their respective types. There are three types of schedulers present in our operating system, that are short-term scheduler, long-term scheduler and medium-term scheduler. As well as we see that the scheduling algorithms are classified into two types, that are preemptive scheduling and non-preemptive scheduling. Preemptive scheduling is a scheduling method where the tasks are mostly assigned with their particular priorities. Sometimes it is important to run a task with higher priority before another lower priority task, even if the lower priority task is still running. At that time, the lower priority task holds some time and resumes when higher priority task finishes its execution. This is all about the preemptive scheduling. Then what is non-preemptive scheduling? In this type of scheduling method, the CPU has been allocated to a specific process. The process that keeps the CPU busy will release the CPU either by switching context or terminating. So, it is only the method that can be used for various hardware platforms. That's because it does not require specified or specialized hardware. For example, consider the timer like preemptive scheduling. And the non-preemptive scheduling occurs when a process vulnerability enters the wait state or the terminate. This is the difference between the preemptive scheduling and the non-preemptive scheduling. Then, now in this lecture, we will see the concept of dispatcher. Dispatcher is one special program which comes into play after the scheduler. The dispatcher is nothing but our one special program of the operating system. After the concept of scheduler, the dispatcher concept arrives. When the scheduler completes its job of selecting a process, then it is the dispatcher which takes that process to the desired state or the desired queue of the operating system. First, we will see what is exactly dispatcher is. We will see the introduction for the dispatcher concept. Dispatcher is the another component involved in the CPU scheduling function is the dispatcher. Dispatcher is the one of the module that is involved in the CPU scheduling function. The dispatcher is the module that gives control of the CPU to the process selected by the short-term scheduler. That means the main function of the dispatcher is assigns ready processes to the CPU. The dispatcher allocates the ready processes to the CPU, to the processor. The CPU scheduling function is the dispatcher, which is the module that gives the control of the CPU to the process selected by the short-term scheduler. This is an dispatcher. And it receives the control in a kernel mode as the result of an interrupt or a system call. Whenever any interrupt or any system call is executed in the operating system, then it receives the control. It receives that control in our kernel mode. The CPU scheduler selects a process among the processes that are ready to execute and allocates the CPU to one of them. So, the short-term schedulers are also known as the dispatchers. That makes the decision of which processes are going to be executed next. This is the dispatcher. Dispatcher is nothing but special program or the special module of the operating system which comes into a scheduling of a number of processes. That means when the scheduler completes its job of selecting a process, then it is the dispatcher which takes that particular process to the desired queue. Whenever the scheduler schedules the job, whenever scheduler completes its job of selecting the process, then the dispatcher task is started. The dispatcher takes a particular process from that queue and assigns or allocate that process to a CPU. This is the main task of the dispatcher. Then what is the difference between dispatcher and scheduler? Consider one situation where various processes are residing in a ready queue and waiting to be executed. Consider the situation, consider the condition, that is, there are number of processes that are residing into the ready queue. That processes are waiting for the execution. Then the CPU cannot execute all of these processes simultaneously. We know that the CPU cannot handle the multiple processes at a time. The CPU cannot execute multiple processes simultaneously. So, the operating system has to choose a particular process on the basis of CPU algorithm is used. So, there is a function of an operating system where operating system chooses a particular process for the execution depending on the particular algorithm. That is, that algorithm is used in the operating system. That algorithms are studied into the we will see that algorithms in the next lecture. There are different algorithms such as first in first serve algorithm, shortest job first algorithm, or priority based algorithm. Depending on the which type of algorithm is used into the operating system, the scheduler selects the particular job for the execution. This procedure of selecting a process among various processes is done by the scheduler. Once the scheduler has selected a process from a queue, then the dispatcher comes into the picture. Whenever a scheduler selects a particular job or particular process for the execution, then after that the dispatcher function arises. The dispatcher concept arises, and it is the dispatcher who takes that particular process from the ready queue and moves it into the running state. The dispatcher selects that particular process from the ready queue and move that particular process to the running state. That means the dispatcher assigns the CPU for that particular process. Therefore, the scheduler gives the dispatcher an ordered list of processes which the dispatcher moves to the CPU over time. This is the dispatcher. So, this function, that means dispatcher functions, involves the following. First one is the switching context, next switching to the user mode, and last one is the jumping to the proper location in the user program to restart that particular program. These are the responsibilities of the dispatcher. Switching context. That means context switch is when a currently running process is halted and all of its data and its process control block, that means PCB, are stored into the main memory, and another process is loaded in its place for the execution. This is the switching context. The switching context is the one of the responsibility of the dispatcher, where context switch is arrived, where the currently running process is halted and all of its PCB are stored into the main memory and another process is loaded for the execution. This is the context switching. Next responsibility of the dispatcher is the switching to the user mode. All of the low-level operating system processes run on the kernel level security address. We know that, but all of the application code and user issued processes run in the application space or the user permission mode. The dispatcher switches the process to the user mode. Here, dispatcher switches the particular process to the user mode for the execution. The dispatcher also having the responsibility of jumping to the proper location in the user program to restart that particular program. The addressing function, the addressing responsibility is also followed by the dispatcher. Where the program counter, that means PC, register points towards the next process that is to be executed. The dispatcher is responsible for the addressing that particular address. We know that the program counter is used to store the next instruction to be executed in our operating system. The dispatcher jumping to the proper location in the user program to restart that particular program. So, the dispatcher follows these functions for the execution of different program by using the proper address location. This is the concept of dispatcher. Then next we will see there are different scheduling criteria. By using that criteria, the scheduling algorithms are actually worked out. There are several different criteria to consider when trying to select a best scheduling algorithm for a particular situation and environment. There are certain criteria that are involved for selecting a different scheduling algorithms. That criteria we will see one by one. Many criteria has been suggested for comparing CPU scheduling algorithms. There are different criteria. Depending on that particular criteria, we are using a particular algorithm for the scheduling. Which characteristics are used for a comparison can make a substantial difference in which algorithm is judged to be best. There are different characteristics. Depending on that particular characteristics, we can easily judge the which algorithm is best for which situation. There are different criteria that include CPU utilization, throughput, turnaround time, waiting time and response time. These are the main criteria for selecting the best scheduling algorithm for a particular situation. Let's see these criteria one by one. First one is the CPU utilization. Utilization means what? Utilize means what? We are using. So, CPU utilization means what? We want to keep the CPU as busy as possible. Conceptually, CPU utilization can range from 0 to 100%. In the operating system, we want to keep the CPU as busy as possible. That means CPU is continuously busy in the execution of different processes. So, ideally, the CPU would be busy 100% of the time. So, as to waste 0 CPU cycles. This is an CPU utilization. The CPU utilization tells that as possible as we want to keep the CPU busy. This is the CPU utilization. Next, throughput. Throughput means what? Output. Throughput, one measure of work, is the number of processes that are completed per time unit. We call it as throughput. Throughput means output. Throughput is an one measure of work. This is an one measure for calculating the work. How the work is calculated? The number of processes that are completed per time unit. That we call as a throughput. Throughput is the amount of work completed in a unit time. In a particular unit time, how much work is completed, that represented by the throughput. In other words, throughput is the processes executed to number of jobs completed in a unit of time. The scheduling algorithm must look to maximize the number of jobs or processes per time unit. For choosing any algorithms, we want to consider the throughput criteria because we want to maximize the throughput in a process execution. That means the number of processes that are executed in a particular time. That means throughput. Next concept is the turnaround time. The interval from the time of submission of the process to the time of completion is the turnaround time. That means a turnaround time refers to the time between movement of the submission of a job or a process in the operating system and the time of its completion. Means submission time and the completion time, the difference is the turnaround time. The turnaround time is the time of submission of the process and to time of completion is the turnaround time. Thus, how long it takes to execute a process, it is also an important factor for selecting a scheduling algorithm. In short, a turnaround time refers to the time between moment of submission of a job or process and the time of its completion. This is the turnaround time. Next one is the waiting time. The waiting time is the sum of periods spent waiting in the ready queue. That means it is a time a job waits for a resource allocation when several jobs are completing in a multi-programming system. The aim is to minimize the waiting time. The waiting time means waiting times is the addition of the time or period spent waiting into the ready queue. Waiting time is the time for a process, for a particular process that is waiting into the ready queue. This is the waiting time. Then last one is the response time. Thus, another measure of the time from the submission of a request until the first response is produced. This measure is called the response time. It is the time it takes to start responding not the time it takes to the output the response. Response time is the another measure of the work where the response time is the time until the first response of the process execution is taken. That means a response time is the time it takes to start responding. That means response time is the another criteria is the time taken from the submission of process of a request until the first response is produced. This measure we called as a response time. In a response time, first response of the particular process is arrived. It is the time at which the first response of a particular process is come. This is the response time. These are the different criteria that are suggested for comparing the different CPU scheduling algorithms. Okay, thank you.